ABC Listen. Podcasts, radio, news, music and more.
A war is developing between China and America over access to critical materials. Beijing has initiated fresh moves to restrict exports of parts that are critical to our smartphones, laptops and cars. Gallium and germanium, which are both needed in the development of semiconductors, are just the latest items in a list of manoeuvres by both Beijing and Washington to limit what the other major power can get access to. This is becoming an increasingly contested space as the big powers race to develop advanced technologies, weaponry and artificial intelligence. But the rise of so-called resource nationalism, as it's known, will affect all of us. Dr. Gavin Harper is from the University of Birmingham Centre for Strategic Elements and Critical Minerals. Welcome to breakfast.
Morning to you, Hamish.
How serious is this?
So I think there's lots of critical materials challenges. We're concerned about a whole range of critical materials, certainly around EV batteries, rare earth magnets. But this, in terms of gallium and germanium, focuses around semiconductor devices. And so the US has restricted the export of key technologies, so lithography technology, which is the technology that's used to transfer the patterns onto semiconductors. They won't export that technology to China. And so in return, China has retaliated by restricting exports by providing a licensing regime around gallium and germanium. And I think, it's unclear at the moment because these supply chains are very complicated. They're quite opaque, but certainly it's predicted to have a degree of impact on a whole range of different technological devices.
Yeah, so I think 80% of the world's gallium comes from China, 60% of the world's germanium comes from China. What's it used for?
That's correct. So it's used in small quantities in some semiconductors to improve certain physical properties. Things like germanium, they're used in satellite solar cells because it makes them much more resistant to cosmic radiation. It's used in infrared devices that are, if you think about infrared cameras, certainly in defence and military applications, night vision and stuff like that. Gallium's used in a range of different materials. So gallium arsenide is used in semiconductors, gives higher performance than silicon semiconductors, lower power consumption, and things like, blue and violet LEDs, light-emitting diodes, microwave devices. Gallium nitride used in a range of different applications, so things like electric vehicles, power electronics, sensors, high-end radio communications, Blu-ray players. So, you can see that even though these materials aren't commonly known to people, they find their way into a whole range of applications that we're really familiar with.
And there are additional geopolitical implications to all of this, are there? Because the bulk of the world's semiconductors are actually manufactured in Taiwan, and the US has also tried to restrict the degree to which those can be moved into China.
Of course. So I think, it's one of those things, again, as I say, supply chains, they're so complicated, they're so opaque. It's unclear at the moment. China has a monopoly control over the materials. America has a monopoly control over the technology. And obviously, there are other producers of these materials, and it remains to be seen how quickly they're going to be able to ramp up supply to fill the void.
Yeah, who are the other producers of these materials? Where else do they come from?
So in terms of germanium, some's produced by Canada, Finland, Russia and the United States. Obviously challenges around Russia. Small amounts of primary gallium are produced by Japan, Russia and South Korea, according to the US Geologic Survey. But, there's a challenge here in that these are relatively minor producers. China has obviously occupied the bulk of that market because it's prepared to tolerate some of the sort of environmental impacts that come from that production. And also it's able to produce it at a cost because of economies of scale.
Obviously, I'm sure we can all understand the threat that this poses to so much of the technology that we all use in day-to-day life. But is this sort of dispute also an opportunity for countries like maybe Australia or Canada, which are rich in mineral resources?
Yeah, for sure. So I think as we see this pivot away from globalisation and just, laissez-faire, leaving the market to deliver the cheapest solution towards countries having more managed industrial and critical material strategies, certainly for a whole range of materials, governments around the world are looking at how to diversify supplies. It's not just about the mining of the materials, it's actually more about the sort of midstream processing, so that bit in the middle that takes the material and then turns it into a suitable material for further applications. So gallium and germanium, they're actually sort of byproducts. They're not mined in their own right. They're byproducts of alumina and zinc production. Some germanium also comes from the fly ash of brown coal. And certainly there's a company a US company, Geospeciality Chemicals, have been looking at a mothballed gallium extraction plant alongside Alcoa's Pinjarra alumina refinery south of Perth. So certainly there's a role there for Australia in helping to meet some of that shortfall.
And are there legitimate concerns about what China might be doing with some of the technologies that are being imported there? I mean, at the origin point of this dispute, are there good reasons?
So I think there's concern when you think about the sorts of devices that could be produced around, defence applications, some of the types of sensors around, night vision, around military applications. This is the reason why America is withholding this technology from China. But I think, there's a real challenge in this pivot towards resource nationalism, that if you sort of expand your view beyond just gallium and germanium and you consider the whole range of critical materials, so many of these are going to be sort of crucial to the energy transition. And we need everyone to do really well at this because, climate change, the energy transition, it's a human race problem that affects everyone. It's not a problem that respects national boundaries. And so we need everyone to get really good at this.
So are you saying that if this evolves further, that it might in fact endanger the planet's energy transition?
So I think, if we look back historically, China has used its monopoly position around, for example, rare earth elements, which are used in wind turbines, electric vehicle motors. And there have been cases with the World Trade Organization in the past about how China has used that monopoly position. And certainly, it depends what happens and how things go forward around the politics. Let's hope sort of cooler heads prevail and supply chains become unstuck. But certainly, there's potential for things to escalate if everyone digs their heels in, and for this to affect a greater range of materials that China does have the monopoly control over at the moment because they've invested in the supply chains and the capacity.
I suspect many of you listening on your smartphones this morning might be wondering how soon before you're affected. How much worse does this need to get before consumers of these more basic products like smartphones and laptops or even cars which use these materials would be impacted?
So I think to a degree, governments around the world have been really vigilant around critical materials. So, the US, EU, UK all have critical materials policy, and certainly gallium and germanium have been on watch lists for the US and the EU. And so companies in that space will be aware of, the potential for instability. So in advance of the deadline for China's export controls, many have been buying up supplies. They'll hold stockpiles in advance. Some companies have said around 6 to 9 months they've got materials in hand. I think, it depends on how long this goes on for. I think it's a case of some applications, there will be other components that can perhaps fulfil that application, but perhaps with a lower degree of performance. So there are some applications where materials can be substituted, but there are others for which these materials remain absolutely essential.
Dr. Gavin Harper, thank you very much.
Thank you, Hamish.
Dr. Gavin Harper is a research fellow with the University of Birmingham.
Find more great ABC RN stories that take you beyond the headlines on the ABC Listen app.